Hey there, it's Jason from Codemanship with further adventures with ChatGPT. So in my previous video, I did some test-driven development with GPT-4. That's the newest version of their large language model. And we test drove some code to solve a business problem. And I tried to keep the roles in our pair programming, if you can call it that, fairly well defined. So I was navigating, I was telling it what to do, and wherever possible, it was writing the code. Now, I did have to, in inverted commas, grab the keyboard a few times because I wasn't always happy with the results. Um, but on the whole, it was a very interesting exercise, and it was very impressive what GPT-4 could do. But I made some observations about just how big a productivity improvement this is going to be for your average developer. And I think I managed to sort of form a place in my head about where GPT-4 might fit into my workflow as a developer and could potentially fit into yours, and the small difference that it might make. But those people who are predicting the death of programming are probably being very, very optimistic about what it's capable of and what you can achieve with it. For sure, you can tell it to do something and it will generate, people have been talking about it generating entire computer games or browser extensions, all that kind of thing. But real software development is much more specific. When you need something specific, then what you tend to find is you need a software developer to intervene pretty much continuously through the process. I also realized that it's better to take with GPT to take small steps, let it bite off a little chunk, and then you can check, read, check, correct it if you need to. So work in those small feedback loops. And the final observation I made about working with GPT-4 was the session that we had, I'm pretty sure that I could have actually written that code faster. Now, to be fair, I was recording a video and I was talking a lot. But even with that taken into account, I'm not sure that GPT-4 really saved me a lot of time. So if you're looking for specific results, specific business rules or requirements, a specific problem domain, specific sort of coding standards or guidelines or specific principles that you're following, then GPT-4 is not quite as big a help as some people are claiming it is. But that's not to say it can't help at all. There were some things it did, particularly in regards to refactoring, that were very impressive. And it got me to thinking, because you get the impression of, as it's responding to you, that it understands and it's thinking at least 90% of the time. Sometimes you get the distinct impression it doesn't understand, but a lot of the time it feels like you're talking to a real developer, albeit quite a junior one. Um, so this sort of comprehension side of it, which we don't know whether it does or it doesn't. And quite frankly, the people who create ChatGPT and tools like that don't really understand what's going on, because it's incredibly complicated. It's so complex that no one really has a handle on what it's doing and what it's likely to do. But we've seen how in the past people tend to anthropomorphize these tools. So maybe some of it is me projecting onto it. And you'll notice in my conversations that I'm very polite with it. And I think maybe subconsciously I'm hedging my bets so that if one day these end up being our robot overlords, I think maybe they'll remember that I was nice to them, that I was polite. Um, but anyway, all that joking aside, the comprehension side of it I think is really interesting because it really did get the impression that it kind of understood what the code was doing. So I thought maybe I would do a little exercise in code comprehension. So I have a little sort of example code base that I use to give me a flavor when I'm working with developers as to what sort of level of training or coaching might be appropriate for them. And one of the things that I hit, you know, very often with less experienced developers is a kind of an inability to wrap their heads around highly composed, highly modular code, particularly object-oriented code. So I put together this little exercise. There's a C# version that we're looking at here. If you go onto my GitHub, Jason Gorman, you'll find that I think there's a JavaScript version as well and a Java version. Um, and it's used by my clients as well for all kinds of reasons. I'm not especially keen on the idea of it being used in programming interviews. If you want to, I suppose you can. I can't stop you. It's out there in public. Um, but and I'll post a link to this repo, by the way, in the description below. But I use it basically just to get a feel for are they really wrapping their heads around this kind of object-oriented code, things like abstractions, polymorphism, dependency injection, that kind of thing. Okay, now we're not going to go into the code here. We're going to see that soon enough. Now this is a session I had yesterday morning with GPT-4, and again the results were surprisingly impressive, and I took it a little further than just code comprehension. We delved into the problem domain itself to see if it was kind of grasping what this code was all about. I asked it to make suggestions about ways in which it could be improved from a sort of a functional point of view, and I asked it to write a bit of code as well. To sort of flesh out the design a bit, so which required it to make some sort of guesses about what it was I was actually asking for, and it was pretty good. I have to say, it was pretty good. So what I'm going to do, rather than just do a whole other session and do it all again, is I'm just going to go through the transcript of the session that we had, and we'll briefly discuss what's going on in this conversation. So I told it that I was going to set it a code comprehension test, and then I was going to paste in some of the code, just the important code from that project, and then ask it a question at the end. So to start with, we've got this class, 30-day sales average. And what this does is it retrieves the total number of sales over the last 30 days, and then it calculates the average number of sales per day. So that's first piece of business logic there. You'll note that 30-day sales implements an interface, I average daily sales. You also notice that sales history has an interface. So this is where we're looking at abstractions and dependency injection. Are developers able to follow this? And now we're going to find out whether GPT-4 is able to follow this. So it calculates, if you ask for the average daily sales for a product, you give it a product, and it will give you a number of the average number of sales per day over the last 30 days. Okay, now, I at that point, I accidentally hit enter. So it complained that it didn't have enough, and I was like, yep, there's more to come. Okay, it can be quite chatty sometimes. It's a little aggravating. So I pasted that in again by mistake, and then I pasted in the program. So there's like a command line program where it's going to be used, where we create this restock level class, an instance of that. We give it something that can fetch product information, or pretend in this case to fetch product information from a warehouse system, and that 30-day sales average implementation we saw there. So we've got two objects being injected into the constructor of restock level, and the comprehension part of this is can you piece together the logic by stitching together in your head the relationships that we're building here in terms of these compositions. So the stub warehouse, which is part of our test code, will pretend to retrieve. We're basically telling, when you're asked for a product, just give us this product object with an ID of 811 and a lead time. That's the number of days we would have to wait for the manufacturer to deliver more of them. In this case, 14 days, and a 30-day sales average, and again, a stub sales history, so something that is going to pretend to go fetch that total across that date range, and we're telling it when you're asked for the sales total over that date range, tell it that the total is 45. So the 45 is hard-coded, the lead time of 14 is hard-coded in the test. Okay, and then we have this calculate method. So we call the calculate method for product 811, and it's going to output the number, the result of that. Now, the restock level, if you think about it, is the number of units of a product that we would expect to sell in the manufacturer's lead time. In other words, if we were to order more from the manufacturer now, how many would we expect to sell before those arrive in the warehouse? So that's what this is really all about. And the question in the comprehension exercise is, what will that program's output be? So you have to kind of stitch the modules together in order to stitch the logic together in order to understand how it will calculate a lead time, which is the sales total over that sales history of 45 divided by 30 days. So 1.5 per day is the average sales per day. The lead time is 14, so the restock level will be 14 times 1.5, which is 21. So that's what we're looking for. And then we can see in our test, we got our stub warehouse, so it will return whatever product we tell it to return. Stubs should never have logic. They should only just return whatever data we say for the test. And we got our stub sales history that will return whatever sales total, we tell it to return between the start date and the end date for that product. So far, so good. Okay, and it goes on to explain a bunch of stuff. Based on the provided code, the program will output the result of the calculate method of the restock level. So it's explaining what the code does, but it's not actually giving me the answer. But it is demonstrating some comprehension of what's going on here. But it is kind of paraphrasing the code. I was very interested because I've spoken with people at Microsoft who've been working on Copilot, and they said one of the big potential selling points of GPT-4 is that it can automatically comment your code. And one of the reasons I'm doing this little exercise is because I was kind of curious, is it really explaining the code, or is it just paraphrasing the code? And what we've got here is paraphrasing of code. It also gets to the bottom and says, I don't have the restock level class, so I can't tell you what the number is. So I apologize, always apologize to the robots, because you never know. One day they could be in charge of you. So I give it the source code for the restock level. It takes a warehouse and an average daily sales object, injected into the constructor. It fetches the product from the warehouse based on the ID. So that's where we can get the product info from. And then we do a bit of maths there to essentially ceiling, get a whole number for the average daily sales multiplied by the product lead time. So now it has enough information. If it can understand the code, if it can comprehend, it has enough information to tell me that the restock level should be 21. The program should output the number 21. Okay, right. And it starts to explain stuff, and I stop it and I go, no, please don't explain it again. Just tell me what is the program's output when it's run. I just want a number, please. Okay, it continues to explain a bit, but eventually 21. So it has figured out how to do the calculation. It has navigated the composition in the code, which is what this comprehension exercise is about. It's a very straightforward exercise, but you'd be surprised. A lot of new developers have never really seen highly composed, highly modular code before, and they struggle to follow it. They haven't really wrapped their heads around objects and polymorphism and dependency injection. So they usually get a number in the end, but it can take some people a long time. It took GPT-4 about 10 seconds to figure out what it was. Now, as far as I'm aware, it can't actually run the code. It can't run the code anyway, because I haven't given it all of the code. So it certainly can't compile it. So it's come up with this number by, in inverted commas, reading and analyzing the code and going, okay, well, if the lead time is 14 and if the total sales of the last 30 days is 45, that gives us a restock level of 21. So it's done that in the way that I would do it, or you would do it. If you're reading code and someone gave you an example and asked you, so what will the output be? Which, by the way, is a great way to test how easy code is to understand, or how good developers are at understanding code, depending on which way round you're coming from it. So I always implore developers, when they're trying to gauge whether their code is easy for other people to follow, don't just ask them. Don't just say, do you understand this code? Do something like this. Give them a little sort of comprehend. Don't call it that, because they may get offended. But try and figure out a way for them to demonstrate that they're able to basically run it in their head. They can fit it in their head. And as we've seen here, GPT-4, however it's doing it, and it's very impressive, can fit it in its head. I'm intending to throw more complex programs at it to see just what the limitations of this comprehension are. But that is, in my opinion, pretty impressive. Faster than a lot of developers can do it. Okay. Right, now, having done that, having been quite impressed with what GPT-4 has done here, despite the fact that it did get into a sort of paraphrasing the code phase there that worried me a little bit, but it did demonstrate that it has understood it, has understood what the code does. Okay, now, we start talking about the domain, the problem domain. So I asked it, what does the restock level mean, do you think? Okay, and this is where it gets pretty impressive. Still quite wordy, but pretty impressive. The restock level represents the quantity of a product that should be ordered or kept in stock to ensure there is enough inventory to meet customer demand, considering the lead time, the time it takes for new stock to arrive. Now, I didn't tell it that. It kind of bolted onto the end of that. Now, my understanding of large language models like GPT-4 is it's kind of Um, it's similar in many ways, apart from some additional logic and algorithms, similar in many ways to what predictive texting does. Have you ever played that game where you're given the start of a sentence and then you just sort of let predictive texting take over, and then you're choosing the words that sound right or sound funny to build a complete sentence or even a complete paragraph. So it's kind of doing that. It's kind of predicting what word, or in its parlance, what token should come next. But when it does it on this massive scale, 175 billion parameters or more, I think that was GPT 3.5, so this is maybe an order of magnitude more than that. When it's trained on that massive amount of text, including program code, you start to see these kind of magical statistical effects. Like when you see lead time in the context of a warehouse and a product, um, we're probably talking about how long it takes to get stock. Um, so it just kind of bolts that text onto the end. So now that concept, those tokens, are built into our conversation somehow, and the average daily sales. In this specific example, the restock level of 21 suggests that 21 units of the product with ID 811 should be ordered or kept in stock to avoid running out of inventory during the lead time of 14 days, given the average daily sales rate over the past 30 days. This helps a business maintain a sufficient stock level and avoid stockouts. In other words, the whole point of this code eventually will be to make sure that we don't lose sales because we're running out of stock, and that's exactly what it's gone for. That's a bloody good guess. I do wonder. I'm trying to think how long ago I started posting Guitar Shack. This is from an exercise called Guitar Shack. I'm trying to think now, remember back how old the Guitar Shack repos are. I think I started doing them with a client in 2020. So that code may well be on GitHub for people to look at. So maybe it's actually been trained on my code. You never know. And it's just regurgitating the code. Right, okay. Over what period of time is average daily sales calculated? Okay, in the provided code, average daily sales is calculated over a period of 30 days. This is determined by the 30 days average sales class. Okay, and then it gets it. It's the past 30 days, the last 30 days average. And here's the relevant code snippet. So we're having a bit of a conversation now. And it does, even though it's quite wordy and stilted, you are aware of the fact that you're talking to a statistical decision tree, if you like. Um, it feels like you are, in many ways, talking to, I would say, maybe even better than a junior developer, maybe even better than someone with maybe 1 or 2 years experience. So, and certainly there's a grasp of the domain here. Again, this is, we have to remember so that we're not fooled. This is just predictive texting on a massive scale. So this is what that looks like. But it is uncanny. It is uncanny. Okay, right. The end date is set to the current date and time. Start date is set 30 days before the end date. The average daily sales is calculated by dividing the total sales within this date range by 30. Okay, now, so there's an element here of paraphrasing the code, but there's an element of what looks strikingly like some kind of insight. It is bringing information into the conversation that is not in the code, and this encourages me a little bit when people make claims about, oh, well, it could auto-comment our code or it could auto-generate documentation. I will make an observation now. I'm going to try this as an experiment. I'm going to do this again, but I'm going to be evil about it, and I'm going to refactor the code so that it's far less obvious what these concepts are. So I'm going to choose some bad names, basically, and see how it gets on with that. How much of this is it pulling out words, names from the code, and then predictive texting what comes next, if you like, but on this very, very sophisticated scale. Can you think of any drawbacks? So this is where we get into a real conversation. Can you think of any drawbacks of calculating the restock level based on the previous 30-day sales? Now, in the exercise, there are all kinds of things that come up. Well, maybe it's a new product and that maybe it's the first day of sales or whatever, and we've already sold out. Or maybe it's a product that we don't sell very, very often. We maybe sell them once every 6 months. So in a guitar shop, that may well be the case. That a £20,000 vintage guitar, you're not going to sell 15 of those in a week. And one in particular comes up, which is seasonal differences. So if I'm calculating this restock level on the 30th of November, and I look back at sales over the previous 30 days, sales are likely to be much lower than they would be for the next 30 days because of the Christmas period, because of the holiday period. Um, Now, it comes up with a bunch of things here that are very interesting. Calculating the restock level on the previous 30-day sales has some potential drawbacks. It goes straight for it. Seasonality, okay, trends and fluctuations. So some things just become popular. I remember when I was a student, everyone went through a phase of all buying mouth organs. I've seen phases of everyone buying all kinds of things from music shops, from guitar shops. It doesn't know, it hasn't picked up on the fact that it's a guitar shop. I would have been very suspicious if it had mentioned that it was actually learning from my code or it had been trained to some extent on guitar shape. But anyway, trends and fluctuations, 30-day average might not capture recent changes in demand or consumer behavior. Promotions and marketing campaigns where we have a push on something we would expect to sell more in the next 30 days than we'd sell in the previous 30 days. One-time events, external factors, natural disasters, supply chain disruptions. We all know a lot about that at the moment. Competitor actions, for example, if someone brings in a large language model into the market, and new products. To address these drawbacks, businesses can consider using more sophisticated inventory management or forecasting techniques that take into account seasonality, blah, blah, blah. So I was very impressed by that. Have it very often has the feel that it is kind of reading from a script. And some people accuse it of, oh, it's just reproducing things that it's seen. I think it's far more sophisticated than that, but that is kind of sort of what it is doing in a much more complex and sophisticated way. So it will never be a direct reproduction, unless I suppose, unless you ask it for it. It will never be a direct reproduction of a body of text because it doesn't store bodies of text, as far as I'm aware. It stores information in a different way that could be thought of as being sort of like compressing the information. So it doesn't have, in the same way that the AI tools that generate paintings or images, they're not storing whole images. They're storing key pieces of information about features of an image. I was reading somewhere that some of these tools like DALL-E and Midjourney, they will store what they know about an image in like 8 bytes. So that's obviously not the whole image. It's not reproducing images. Sometimes it may get really, really close to something that it's been trained on, but more often than not, what it's producing is, in that sense, original, statistically original. But in terms of the ideas, not original. It's not having any original ideas here, so it is reproducing in some way. Um, okay, could you suggest? So this is where I'm like, well, I'm not going to get into something sophisticated. Let's try and do something simple. Could you suggest a simple way to factor seasonality into the calculation of restock level? And the answer is no. So it went through a whole bunch of suggestions here, all of which I didn't consider to be particularly simple. So it plumped for having a sort of a seasonality index for every month. And I thought, well, there must be an easy way. I think the problem is that we're looking back. What if we were to look at average daily sales going forward? Now, of course, we can't travel in time and go, well, what will be the average daily sales over the next 30 days? But we could go back in time to the next 30 days in the previous years. So I said, look, please, oops, does this not have the drawback of looking back at the previous 30 days to predict sales going forward? Yes, you're correct. The modified for product method I provided still has the drawback of looking back, basically. So to better handle this drawback, you can consider the following approaches. Use historical seasonality instead of the previous 30 days, the next 30 days, moving averages, exponential smoothing, advanced forecasting messages. So we're still, and then it kind of, basically at this point, it kind of banged out. It timed up. We had a few of these time maps over the session. So I prompted it to keep going. Ultimately, the best approach, blah, blah, blah. So I'm like, okay, I'll throw you a bone here. Might it be simpler to calculate the average daily sales for the next 30 days in previous years? So it agrees. So yes, calculating average daily sales for the same 30-day period in previous years I do wonder how easily led it is. It has argued with me a couple of times about points on code quality, for example, or coding conventions, which we'll talk about in a minute, actually. But more often than not, it'll go, yes, you're right. It hasn't argued me on these kind of points. So I do wonder how gullible it really is, how easily led it is. Yes, calculating the average daily sales for the same, which, by the way, would be a real drawback. As some people that I've been talking to about GPT-4 have said, look, when this gets integrated into our development workflows in a better way, we're thinking we can kind of leave junior developers with GPT-4 or with Copilot incorporating GPT-4. I think that would be a bad idea, because you'll either have developers just blindly accepting whatever GPT-4 gives them, which is, as I demonstrated in the previous videos, would be a mistake. Or would be in a position, would be able to essentially influence GPT for the worst. Yeah, I'm not sure about that at all. Yes, calculating average daily sales for the same 30-day period in previous years could be a simpler and more effective approach to account for seasonality. It then goes on to generate some code where it essentially does a query over previous years, and we tell it the number of years we want it to do it for, and it then calculates a kind of an average based on total sales over that whole set of periods. So something that is more reflective of sales going forward in terms of seasonality than sales going back. So I was reasonably satisfied with this. I don't know whether it realizes that it would be connecting to a web service over and over again. I did think about having an architectural discussion with it about whether it would be better to adapt the sales history system to just give us the average or just give us the total over those periods, so that we only have to talk to it once, because that's where the data lives. But I decided not to go down that road. I decided just, okay, this'll do for now. Let's live with this. I do like its choice of names. That's good. In this modified method, you provide the number of years of historical data to consider, and this calculates the average daily sales for the same 30-day period in each of those years. Blah, 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 blah. Okay. Now, we get into another discussion, which is sort of really, again, about the problem domain. In the production environment, when do you think calculate will be triggered? So it takes a bunch of reasonable guesses here. In a production environment, the calculate method could be triggered under various scenarios. Periodic inventory review of overnight jobs or weekly jobs or whatever. Reaching with the reorder point. I don't know how we would know we were at the reorder point without calculating the restock level. So that's a kind of a bit of circular logic there. Unless it's a hard-coded reorder point, but it doesn't quite get that the restock level is the reorder point. An inventory management event, so I'm not sure how it thinks receiving new shipments would trigger calculating the restock level, because what we're interested in is when does the stock hit the restock level, and the answer to that question is it's ambiguous, but it may be thinking here that it's moving in both directions, that if we hit the restock level, we should stop ordering more. So it's kind of getting a bit confused here, but okay, fair enough. Or a manual request. So the store manager or someone in the stock room or whatever says, okay, I think for this product we need to know what the restock level is at the moment. So it's worth noting the exact trigger for the calculate method depends on the inventory management system and business processes in place. Fair enough. Very, very generic. You will often get things from GPT-4 that are very generic. So it's not really telling you very much at all. Okay, now we get into it. If inventory management is real time, what's the most obvious business event that could cause a product stock to cross the restock level? I'll give you a clue. You didn't mention it yet. Okay, so I threw in another bone there. Whether that helps or not, I don't know. My apologies for not mentioning it earlier. So I think it picks up on the word mentioning and then like predictive texting, but in a very sophisticated way, just keeps on going. The most obvious business event that could cause a product stock to cross the restock level in a real-time inventory management system. So it will kind of read the question back to you before it tells you the answer, which is slightly annoying, is a customer purchase or sale. When a customer buys, so bingo, right, on a sale event. So whenever we make a sale, we need to know is it time to order more, basically? So it's hit the nail on the head here. So then I want to then this is something I would sometimes do if we've got time. If we go through this code comprehension exercise, we would discuss these sort of requirements issues, and then we would get onto the topic of writing more code. Then I would look to see what they're like at writing code, sort of to extend this little design. Could you write a new class that handles sales events that will be triggered by a message from the point of sale system? I hope it knows what that means. Don't worry about how the message is sent, just focus on the core logic of handling the event. That uses our code to determine, so the code that we've already got, that uses our code to determine if a product needs to be reordered and then sends an email to the store manager to order more. Assume the store manager will decide how to place that order from the manufacturer and for how many units. So our system is not responsible for making those decisions or doing that work. It's responsible for alerting the store manager that a product needs to be reordered. Okay, off it goes. It writes the code for us. Again, a fairly wordy implementation. Now, I am curious because I've spoken to people who said, "Oh, I've generated a complete application," and it's like a whole computer game or something. It won't do that for me. It'll generate bits of it, snippets of it, to sort of give me a flavor of this is what you need to do, and this will go here, and this will go there. And then you have to figure everything else in terms of project structure and namespaces and all that kind of stuff, plus getting it all set up. It does mention NuGet settings, and we'll see that in a minute. So it does give me some advice, but people saying, oh, you won't need to be, for example, a C# or a .NET programmer to write programs anymore, because this will do it all for you. Not that I've seen. Honestly, not that I've seen. And I have tried, in previous experiments that didn't go very well at all. So look, can you show me the whole code listing? And what it does is it just generates it again. It rewrites it. Remember, this is a statistical process. You never really get the same result twice. It is not a code repo. It generates code, and it generates it using very complex statistical logic. And therefore, it was trying to nail down jelly, basically, in the sense that it just kept moving the goalposts. So in the attempts I made, I never could get a complete source listing. And even if I could, I would have had to have known what to do with it. I would have had to have been a .NET developer. I've had to be able to use Visual Studio, VS Code, or in my case, Rider, to put all of that together. It doesn't do the whole thing for you. It really doesn't. I don't know where that idea comes from. Okay. I've yet to see someone who isn't a programmer make that claim. Notable. Okay, right. So it generates some code for us. So we've got this sales event handler. Okay, that'll do. We've got a handle sale event. It's generating comments there that I don't think are particularly helpful. And as you can see, it hasn't generated the whole thing. So it's kind of sort of. But it didn't. In actual fact, I think maybe some of that code is missing. That's interesting. Okay, please assume the point of sale system also communicates directly with the warehouse. So so that is not the complete code. Some of that code is missing from our transcript. What it was doing was essentially getting the product information from the warehouse and then doing it again inside that update stock. It's made the assumption here that it is responsible, this system, our system, is responsible for updating the warehouse system. It is not. So please assume the point of sale system, so it kind of made up a requirement. It assumed that it wanted us to do that. Please assume that the point of sale system also communicates directly with the warehouse, so there is no need to update the inventory. So sales records and inventory are handled by external systems independently. Okay, so they're read-only, basically. And what we're getting is the current stock, that is the amount we have in stock before that sale that we're handling here has been fulfilled for that particular product. Okay, so add that field. Okay, so it's add the field to the product class, so we've got that information. And now it's actually fetching the product. So it assumes that we've already fetched the product. And so we're just passing the product in. Now, the problem with that is that calculate also fetches the product from the warehouse system. So we're fetching the same product twice. So I made that point. You can see there's the details of the email that are being sent. You'll notice later that the details mysteriously change. Okay. This design now has our code retrieving product information from the warehouse twice. Once before we call handle cell, so outside that handle cell method, you've got to fetch the product. And again, inside calculate, so I ask it to refactor the code. It agrees and it refactors the code, so pretty good there. So now we're actually passing the product into calculate and the sales of that handler class there. So in other words, we're fetching the product outside handle sale, passing that in. We're only fetching it once, okay? And then it does its little calculation there. It figures out how much remaining stock we've got after we fulfill the sale. It does the little calculation, and then it checks to see is that remaining stock less than the restock threshold. Now, interesting. Now, I didn't get into this with it, but I was sort of wondering whether it should be less than or equal to. But it assumed less than. It assumed less than. And I wonder if that's because I used the word crossed. I said it crossed the restock threshold. But there again is something where it might need to be challenged. It might need to be challenged. Okay, right. Scrolling on down further. Okay, then we go on a little bit further, and in the real Guitar Shack exercise, it's a web service that the point of sale system can talk to whenever a sale is made. So I ask it to write me an ASP.NET Core web service for the handle sale method. Okay, so it generates all of that for me, a lot of boilerplate and blah, blah, blah. It mentions there, you'll see that we have, okay, no, it doesn't mention it here. Should mention it somewhere, but you get, but anyway. Okay, there's our startup file. I'm not sure why, I suppose they could be singletons, not sure why they need to be. We could just instantiate them every time because they are stateless. So we could have had a conversation about why we don't need them as these objects as singletons because they are stateless. Okay. And not a big fan of the singleton pattern in these kinds of situations. And it gives some advice there about setting it up and so on and so forth. And then it says we send a JSON payload with the product information. Now it's misunderstood here. The point of sale system doesn't have the product information; it just has the product ID. So we're the ones who have to fetch that from the warehouse, as we've done. So I ask it to rewrite the code to fetch the product ourselves, like that. So our sales request now, the web service that the point of sale system calls, just needs to give us a product ID, and we'll fetch the product information about the current stock and the lead time. Okay. So it redoes the code for me there, and at that point, I'm relatively happy with the code. Relatively happy with the code. Okay, now it's changed the output here. So it did this a couple of times and changed the output of the web service, but that's okay. If we had specific requirements about that, that would be very annoying. But anyway, it's added all of our classes there as singletons. As I said, I was going to have a conversation with it, but at this point I was starting to get, frankly, a little bored. So I thought, well, let's round this off. Let's round this off. So again, if we were doing this exercise with a new developer, there'd be other things I might want to explore. And one of the things I might want to explore is unit testing. Can they write unit tests? So at this point, let's just keep going. Right. Okay, there was one more. Yeah, so I've said, look, can you write me 2 end unit tests? One where an email is sent to the store manager, in other words, a product needs restocking, and one where an email is not sent, in other words, we don't hit the restock level after a sale. So it had to go. It gave me some advice on how to set up. I'm constantly having to remind developers to add all of those NuGet dependencies, by the way. That was good that it reminded me. Create a new test project, blah, 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 right. Okay, so it sets up a setup method for the test. Interestingly, it didn't do that when I'll show you in a minute. When I was working in Python, we were doing an exercise in Python a few days ago. It followed different conventions, and I think that is just because Python developer culture is different. They have different standards and different ways of doing things. So I thought that was very interesting, though. Okay, so there's the setup for our test. We creates our test product with a current stock of 100, sets up a stub sales history with 30 sales over the next 30 days in previous years. In other words, the average is going to be one sale per day. Okay, and a lead time of 14. Okay, so the restock level for this is going to be 14 times the average sales per day, which is 1, so it's going to be 14. So a restock level of 14. Okay, now it sets up a quantity sold of 80, calls handle sale for that product, and then assert. So it's created what it calls a stub email service to check whether or not send email was actually called on its interface. Now we'll talk about that in a minute. I did have a conversation with GPT-4 about this. Now, sort of doing it in my head, if average sales is 1 per day and the current stock is 100, this test will fail. If we sell 80, unless my eyes are playing tricks on me, if we sell 80, we'll have 6 left before. In fact, it'll be 7 because it's less than the current stock less is the remaining stock less than the restock level. So this shouldn't actually send an email. So that was very interesting. Okay, and then well, definitely here it shouldn't send an email. So the second test is fine. And then we've got the stub email service at the end here. We've got our stub sales history and everything else as well. But we've got the stub email service essentially that remembers if the send email method is called. So it's a hand-rolled test double, but it's not, strictly speaking, what we call a stub. Well, let's take a look. So is email service really a stub, or is it playing some other role in the tests? You are correct. My earlier response incorrectly labeled email service as a stub, while it actually serves as a mock object. So it got that right eventually. But I've got every reason to believe, from what I've seen of GPT-4 so far, that the next test I write that needs mocks, it'll just do it again and again and again. But we'll talk about that. Okay, so now it just renames it. And that's fair enough. You don't have to use a mocking framework. But I thought as a sort of a last part of it, I basically said, could you rewrite the tests using the mocking framework called mock, M-O-Q for .NET. So it knew kind of sort of how to do that. So it creates a mock email service and passes in its .object property. So mock is a little strange in the sense that the mock object is not an instance of the object itself. It's not the thing with the iEmail service interface. That's a property of the mock object. So it's a little roundhouses, but there you go. Okay, so it's done it there. Same data as before. There's our test. It sells 80, which should not trigger an email alert. So the test is still wrong, but assuming that we chose the right data for that particular test, then I'm going to have to do this I'm going to paste this, after I watch this video, I'm going to paste this code in, and we're going to try and see whether it actually does pass. And then in the second test, it's done the same thing. It's written it using a verify rather than what it was doing before. So I'm happy with that result. Interestingly, in .NET, it follows a convention where it comments the setup and the action and the assertions in the test with arrange, act, assert. So that's what I was talking about, where it seems to do different things depending on which programming language we're working on. So in the Python example I did a few days ago, you'll see it uses given, when, then, the sort of the Gherkin syntax, the BDD syntax. So in the .NET world, it's arrange, act, assert, but apparently in the Python world, it's given, when, then. And there's a little clue there about how GPT-4 works and how it learns. It kind of follows, and I'm not saying that's any worse than what a lot of developers do. It just does it. It might even have a rationale for doing it, but it's this. If you think about it, it's an identical rationale, two different results. And also, I told it to not use comments in the tests, and I told it to not write multiple assertions in the tests. It very dutifully refactored that. It argued about the comments, but then when I said, no, please, do it, it dutifully refactored the test code to my satisfaction. But then the very next test, it did it all again, given when then multiple assertions, and it did it over and over again, no matter how many times I told it. So that's something to watch out for. That's really annoying, having to constantly rework things or correct things that it seems incapable of learning. But there you go. So that was our. Let's go all the way down to the bottom again. So that was my little conversation with GPT-4. I was pleasantly surprised at how well it did at this comprehension test. If this was a job interview, like I said, I suppose if you want to use something like this for an interview, you can. But if this was a job interview, I think that I would be very much considering hiring GPT-4 for a kind of internship or an apprentice level developer role. Because it's displaying a lot of, in inverted commas, intelligence. It's not necessarily real intelligence. We don't really know. Um, but it got a lot of stuff right. It got a lot of stuff right. Far better, I suspect, than GPT 3.5 would have done at this. It waffled a bit. It made some stuff up. It made some assumptions. It wrote some code I didn't ask for. But when have you worked with a developer that didn't do that? But you do need to be there throughout this process. And it was kind of fun. It did feel like I was having a real conversation, albeit with the world's dullest person. But it did really feel like I was having a real conversation. Maybe we'll try humor with it next time. Maybe maybe I'll try doing a pairing exercise, maybe a TDD exercise in the style of Blackadder and Baldric and see what happens. But for now, this has been a really interesting exercise. I hope it's given you some more insights into GPT-4 and what it is capable of. And in particular, if you're thinking of using it as a sounding board. So that's kind of what I've done here for a lot of this stuff, using it as a sounding board. And I did find it in much the same way that having an inflatable parrot that you can talk to can be really helpful. I think this is like a step up from an inflatable parrot in the sense that it's giving you some meaningful responses and some meaningful ideas. So again, the programmer cannot be taken out of the picture. The driver needs to be in the front seat, even if the car's driving itself. You need someone with a license. And a similar kind of deal here. This I think, would be useful for programmers. I am skeptical about how useful it would be for junior programmers or for less experienced programmers, because I can see situations where GPT-4 is telling it things or generating code that's wrong, or that is misleading, or that it hallucinates. I think it still kind of does that. Or flipping that over, get into a situation where the junior programmer is essentially leading GPT down the wrong road, down the wrong path, and neither would know it. That's that situation, that pairing situation where they're both beginners, and that can be very risky. Sometimes unavoidable, but it can be very risky. Okay, I'm going to park this here. This has been an interesting exercise. I had promised to do another video where I was going to do some TDD with GPT-4, maybe do the same exercise again in a new session, but this time flip it around and have GPT-4 navigating, so telling me what code to write and what refactorings to do, and me driving and seeing I've not seen anybody do that yet. And it does take me into some uncomfortable territory about from that point of view of having an AI telling a programmer what to do. I think that does lead us potentially into an area where we're essentially being managed or supervised by software, which I'm not a big fan of. I think it should always really ideally work the other way around. But I think it would be an interesting exercise to see whether it's capable of it. Obviously, it's capable of understanding in inverted commas because it understands nothing. Keep reminding myself of that. It's just a statistical model. But it gives the impression that it understands retail and inventory management, stock control, all that kind of stuff, and is able to apply that to a particular problem, a very specific problem. Okay, good stuff. So my adventures with GPT-4 will continue. If all goes well, in the next video, we will be doing some more pair programming, some more TDD, but this time we'll be flipping it around, as I said. So take care. Oh, and by the way, if you've come across things like ShareGPT, which I've only recently just heard about and signed up for, so thanks for pointing that out, the person who commented on the last video. So I will be posting these transcripts, links to these transcripts on ShareGPT in the description below. So you can go through the whole thing in detail if you want to. Okay, thanks for listening. Until the next time.